Hello students, hello everyone. In this video, I am going to discuss a most important topic, that is Boolean algebra. For the students of class 12th who have opted computer science and in ICC board. Okay, and let me tell you the importance of this topic. This topic Boolean algebra covers 30 marks out of 70 marks. So now you can think how important this topic is. Okay, so in this video, I am going to discuss that, and I will try to cover most of the topics in this video, and that will be useful for revision at the time of examination. So one short video, you can say, like that I have prepared. Okay, I will show you. And so without wasting your and my time, let's introduce what is Boolean algebra and where we use it, and then I will discuss the other topics. Okay, so Boolean algebra, let me tell you, this Boolean algebra, this algebra will be used in the field of computer hardware. This algebra, this theory, whatever I am going to teach, or what we are going to learn, it will be used in designing the circuits of computer. ठीक है, कंप्यूटर के सर्किट्स को डिजाइन करने के लिए में ये थियरी, ये प्रिंसिपल्स, ये अलजेब्रा यूज होता है. तो दिस इज द इंपॉर्टेंस ऑफ दिस बुलियन अलजेब्रा. Practically I am telling you, if you want to know ki what is use of this, learning this theory, this algebra will be used if you go in the field of computer hardware. Okay, and you will design the circuit for the computer. Okay, so there it will be used. I hope it is clear to everyone. And so this this topic, in this topic, I'm going to discuss and the father of this algebra is George Boole. In the name of him, this is called Boolean algebra. George Boole ke name pe, George Boole is the father of this Boolean algebra. So on his name, the name of this algebra is Boolean algebra. Okay, so let's start without wasting your and my time. Here we go with the topics under Boolean algebra. The first topic you can see on the screen, I have written proposition, logic and hardware. This is the topic name which you will get in your syllabus. Okay, I'm coming to first topic under this, that is proposition. You can see the definition I have written. A proposition is a sentence or statement that may be either true or false. Okay, it means it's a statement which result will be either true or false, nothing else. True or false के अलावा जिसका result कुछ भी ना हो, that is called a proposition. Okay, just take care, it is not preposition, it is proposition. I am not teaching English, I am teaching algebra. Okay, Boolean algebra. So for example, here it is one example of proposition is given here. It is raining. Okay, so consider while you are watching this video, if it is raining, the result of this statement is what? True, if it is raining while you are watching the video. And if it is not raining, then the result of this is what? False. So it's a proposition. Second, I'm telling you, it is India is a continent. As you know, India is not a continent. So the result of this statement is what? False. So the statements which may be either true or false are called propositions. Okay, I hope it is clear. Now coming to this, in Boolean algebra, there are only two values, 1 and 0. That one stands for true and 0 stands for false. सिर्फ दो ही वैल्यू है Boolean algebra में. ठीक है, तुम्हारे algebra में बहुत सारी वैल्यूज है, बट Boolean algebra में सिर्फ दो ही वैल्यू है, true and false. True is represented by 1 and false is represented by the 0. Okay, so here everything is based on that 0 and 1 only. Okay, now coming to the next topic, that is connectives. Okay, connectives are the symbols which are used to join two or more propositions. Okay, some 5 connectives I am going to teach you. Here there are 5 connectives in Boolean algebra. You can see on the screen: conjunction, disjunction, negation, implication and equivalence. So these are the symbols which are used to join two or more propositions. The first is conjunction. Okay, conjunction. So the symbol used for conjunction, another name of conjunction is and. Actually, and or not, these are the logical operations, in Java, if you studied Java. So conjunction means it is also called and. The symbol used for conjunction is dot, and sometimes this symbol, ये vertical, this V, be in this shape. Okay. These two symbols are used for AND operation. What you have to do, what you are going to do, you have to remember these symbols. These symbols are used for conjunction, dot and this symbol used for conjunction, that is for AND operation. Okay. Another connective is disjunction OR. Okay. For this OR operation, the symbols which are used is plus and this V symbol. Either one will be used. Let me show you here. Consider P and Q are two propositions. So we can show conjunction or AND like this, P and Q. Dot symbol can be used, or you can use P and Q like this. Same thing for disjunction. This symbols P plus Q can be written. Consider here P and Q are what? Propositions, or it can be written as P or Q. So you need to remember these symbols. Okay, the meaning of these symbols must be clear. These are what symbols are called? Connectives. Okay. Now negation. For negation, there are three symbols. One is bar, another is dash, and third one is this tilde symbol. Okay. So let me explain with example. P bar, or it can be written as P dash, or it can be written as not P. Three symbols are used. Any one of them can be used. So P bar, P dash, or not P. It is read as not P. The symbol name is tilde symbol. Okay. It is, you can find this in the keyboard, you will have. So for negation, there are three symbols are used: bar, dash, or the tilde symbol. Okay. Now next is implication. Only you need to learn what is the symbols. Okay. Implication means if then. It is also called conditional proposition. It is used for conditional proposition. Implication means the symbol used for implication is this, or it can be used like this also, arrow symbol. You know, in maths, imply that. Have you heard the same thing here? For example, let me show you. P and Q are two propositions. So P implies Q. The meaning of this: if P, then Q. It is what? Conditional proposition. Remember this. If P, then Q. The meaning of this. Okay. P implies Q, or it can be written as P implies Q. Okay. Now, and next is equivalence. It is for if and only if, or it is also called biconditional propositions. The symbol for biconditional proposition is what? This symbol, both sided arrow. Okay, or this. Any one of these symbol can be used. For example, P equivalent to Q, or same thing, P equivalent to Q. So please remember these symbols: dot for and, plus for or, okay, then dash, bar, and this symbol for negation. So please remember all these symbols. Okay, you need to remember these connective symbols which are used to connect two or more propositions. Okay. Now coming to the next topic here. Well formed formula. Okay, well, WFF, it is not WWF, please see carefully, this is WFF. WFF is the full form of it is well formed formula. Actually, the proposition is also called WFF. Okay, so proposition is also referred as WFF. Once they had given a question key, what is the difference between WFF and proposition? So there is no difference, they are same. Okay, so you can see they are same, or you can write the definition, both are same. Okay. Now coming to the next topic, truth values. Truth values, you know, there are only two truth values, true and false. As I told, in Boolean algebra, there are only two values, and that is true and false. And these are called truth values. Okay. Truth values are defined as truth or falsity of a proposition. There are two truth values, true and false. Okay. So true and false are what? These are truth values. Consider there is a proposition, it is raining. So if it is raining, what is the truth for this proposition? True. And if it is not raining, what is the truth for this proposition? It is raining? False. So it is called, that's what it is called. They are called truth values. Okay. Now truth table. Truth table is a list of all possible truth values of a proposition. Okay. I will come back to this definition afterwards. I will draw and teach some truth tables. Then I will come back to this definition. What is the meaning of this truth table? We'll learn it. Okay. So coming to the now, I'm going to draw and tell you how to draw the truth tables for different connectives or for different operations: conjunction, rejection, negation, implication, and equivalence. For all these, how to draw the truth table, that I'm going to teach you. Okay, for conjunction, see, for conjunction, I'm going to draw the truth table. So consider there are two propositions, P and Q. So if there are two propositions, how to draw the truth table for them is, kindly learn it. Two propositions, P and Q. So to draw the truth table for this, here, how many propositions? Two propositions. So how many possible combination will be there? Here P is a proposition, Q is a proposition. So the possible value of P will be what? Only P will be what? 0 and 1. As I told, there are only two values in Boolean algebra, 0 and 1. 0 stands for false, 1 stands for true. Like that, the possible value of Q will be what? 0 and 1 only. Okay. So if we have two propositions P and Q, so then how many possible combinations will be there? As you know, in maths probability, if you know, there will be 2 to the power n possible combinations if there are two propositions. So here, how many propositions? Two propositions. So 2 to the power 2 means how many possible combinations will be there? 4 combinations will be there. So that I'm going to write. If you know, if you're tossing two coins, so head, tail, head, like that. The same thing here. So here possible value of P and Q will be 0, 0, 0, 1, 1, 0, and 1, 1. These are the possible combinations of P and Q. Okay, and actually this is the binary code of 0, this is the binary code of 1, this is the binary code of 2, and this is the binary code of 3 actually. Please remember this, it starts from 0, the binary code of 0, binary code of 1, binary code of 2, and binary code of 3. Okay, and easy way to learn, I'm going to tell you, you can learn how to draw the truth table for two propositions. Just learn it. 0, 0, 1, 1. I hope it is clear to everyone. 0, 0, 1, 1. Vertically see 0, 1, 0, 1. 0, 0, 1, 1, 0, 1, 0, 1. This is the easiest way to learn to draw the truth table for two propositions. Further, I will tell you how to draw the truth table for three propositions and four propositions also. Okay. Now we are going to, since we are drawing the truth table for which operation? AND operation, that is also called conjunction. So a symbol for conjunction is what, or AND is what? Dot. Two symbols are there. Any one of them can be used. So here I am using dot symbol. And another symbol is this one, if you remember. Okay. So I am going to draw this. So rule for conjunction is what? If any one of the input is 0, you can see it say, if any one of the proposition is 0, then the output will be 0. एक भी 0 होगा तो 0 होगा. So here 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. If any one of the proposition is 0, the output will be 0. Okay. So this is the truth table of what? Conjunction and operation. Okay. So I'm coming back to the definition of truth table. A truth table is the list of all possible truth values of a proposition. You can see this truth table. All possible truth values of a proposition it has. So it is the list of all possible truth values of a proposition. All possible values of P, all possible values of Q, all possible values of P and Q. Okay, are you getting this point? So what is the truth table? Truth table is the list of all possible truth values of a proposition. I hope the definition of truth table is also clear to everyone. If any doubt, if any doubt, you can ask through the comment section. Now coming to the next, disjunction. Disjunction, that is also called OR. So same thing I'm going to do here too. I'm going to draw the truth table for two propositions. Here I'm taking P and Q. And as I told, the easy way to learn, you can draw, fill like that. 0, 0, 1, 1, 0, 1, 0, 1. Okay. Now the symbol for OR is what? Plus symbol. So here we can use P plus Q. Another symbol is this. So any one of that symbol can be used. Okay. The rule for conjunction is what? Disjunction. Sorry, disjunction is what? If any one of the input or any one of the proposition is 1, the output will be 1. So here 0, 1, 1, 1. एक भी 1 होगा तो output 1 आएगा. This is for disjunction. Okay. Now I'm going to discuss about the conjunction. So conjunction done, disjunction done. Now third is what? Negation. Negation, here we have only one proposition. It's a unary, you can say. एक ही होता है इसमें. One proposition. So consider one proposition is P. So the possible value of P will be what? Only one proposition we have to take here. It works on only one proposition. The what is this? The possible value of P will be what? 0 or 1 only. Okay. And you know symbol, now we are going to draw the truth table for what? We are drawing the truth table for not operation. So the symbol used for not operation is P bar, P dash, or that tilde symbol. So any one of that three can be used, you know, P dash or P bar or this tilde symbol. Okay. So I am using this dash here. So whichever is convenient for you can use, but if in examination any one of these three symbols are coming, just remember them. Just try to identify them. You must remember this, all three symbols. So P dash, so 0, the negation of 0 will be 1 and the negation of 1 will be 0. Okay, and it is also called complement of the proposition. Means complement of P is what? P dash. Complement of 0 is what? 1. Complement of 1 is what? 0. So dash is also called, this negation is also called complement. Okay, remember this. Remember this. Then this is the for negation. Okay. Then next is implication. It is already drawn. But I will draw it again for you all. Implication, that is also called conditional proposition, and the symbol, you know, that arrow symbol is used for implication. Let me draw again. For P and Q, P implies PQ, and the easy way to draw, you know, 0, 0, 1, 1, 0, 1, 0, 1. Learn it, please. So how to draw the truth table for two proposition. Now, for implication, so P implies Q. Okay, draw the truth table for P implies Q. So rule is here what? Let me show you. Here if P and implies Q, so this part is called antecedent. Okay, and this part is called consequent. Okay, so rule is what? Here I have written, I think. If antecedent is 1, and consequent is 0, then output is 0, otherwise 1. If antecedent is 1 and consequent is 0, then output is 1. So you can see only here. So the output is 0, sorry, output is 0. You can see only this situation, antecedent is P and consequent is Q. The antecedent is 1 and consequent is 0. Only here we have that situation. So only for this, the output will be 0. For rest, it will be 1. Okay, let me show you in one more column. Here we have written P implies Q. Now I'm going to write for Q implies P. Now the antecedent is what? Now the antecedent is Q, and antecedent is what? Q, and consequent is what? P. So now we'll see Q and P. Okay, so where antecedent is 1, you can see where antecedent is 1 and consequent is 0, then output will be 0. Okay, so only for this the output will be 0. For rest it will be 1. I think it's clear to everyone. Just like this. If it is not clear, let me divide it. Okay, don't draw this horizontal line. To make it clear, I have drawn. No need of that. So here it is. I think the things are clear. But here, so you can see the P implies Q is not equal to Q implies P. Okay, both columns are not same. So where antecedent is 1 and consequent is 0, the output will be 0. For rest, it will be 1. Okay, this is for implication. Remember this rule I have written. By pausing the video, you can write what make the notes also. The last truth table for equivalence I'm going to draw. Biconditional, it is also called biconditional. Okay. So here I'm going to draw for P and Q, P, Q, and the symbol for equivalence, this equivalent symbol is P equivalent Q. And easy way to draw, 0, 0, 1, 1. Okay. Then 0, 1, 0, 1. Okay. Now rule is what? The rule for this equivalence is what? If both are equal, the output will be 1, otherwise 0. Here it is. If both inputs are equal, then the output is 1, otherwise 0. So you can see the first and last row, here both are equal. In this first row, both are equal. So here output will be 1. And at last row also, you can see both are equal. So here also the output will be 1. And for rest, it will be 0, 0. Where both inputs are equal, then the output is 1, otherwise 0. So these are the truth table for all that you can say connectives, or for conjunction, disjunction, negation, implication, and equivalence. Okay. Now I'm going to discuss some terms which are used in Boolean algebra. These terms are very important. Just don't ignore it, and don't think this is theoretical part. So no need to take care of this. Take care of this. These things are very important. Okay. So related terms are here. Some terms which we use in Boolean algebra that I'm going to discuss here. Okay, one by one you can see everything is in front of you. So you can go one by one. Here the first term is what? Contingencies. Okay. Contingency is what? The propositions that have the combination of 0 and 1 in their truth table column. The propositions that have the combination of 0 and 1 in their truth table column are called contingencies. Okay, let me show you. See all these previous truth table which you have already drawn. See the last column of every truth table. See this column is called, the column which has the final result is called truth table column. Please listen carefully. Truth table column. It is not, we are not talking about the truth table, we are talking about the truth table column. What is the truth table column? The final column, the last column which has the final result. That is called truth table column. So you can see the truth table column is the last column of each truth table which you have drawn has the combination of 0 and 1. So these all propositions are example of contingency. See the last column of every truth table column of every truth table, you can see has the combination of 0 and 1. So such propositions are called contingencies. So above all the propositions are what? Example of contingencies. Okay. Next is what? Tautologies. Sometimes it will also happen that truth table column of a proposition will have only ones in that last column, in that truth table column. Just focus on this word. If the proposition that have only zeros, so only ones in their truth table column are called, then that such propositions are called tautologies. Further, if you'll go through the questions and you'll solve the questions, you'll draw the truth table. Sometimes you'll get only ones in that last column. Okay, so that proposition is called tautology. Like that, contradictions. Same, the proposition that have only zeros in their truth table column. Sometimes you'll get such things also. If you draw the truth table, and if you go, and then you'll get the only zeros in that truth table column, the last column. Okay, so that proposition will be called contradiction. So see, these three terms are interrelated. If there is a combination of 0 and 1 in that truth table column, in that last column, that is called contingency. If only one, tautology. If only zeros, contradiction. I hope these definitions are interrelated, so will be easy to learn. Okay. So please remember these words: contingency, tautology, and contradiction. Sometimes you may have a question, Boolean equation, and you have to verify or prove whether it is tautology, contradiction, or contingency. So if you're getting only zeros, contradiction. If you're getting only ones in the last column, tautology. Or if you're getting the combination of 0 and 1, then it is called, that will be called contingencies. Okay? Contingency. Now coming to the next term, converse, inverse, and contrapose. These three terms are also interconnected, interrelated. If you understand one, next two will also will get. Okay. So coming to the converse. Converse means, you can read the definition here. I am going to explain. The converse of a conditional proposition. All these three terms are related to conditional proposition. You know conditional proposition, this P implies Q is called conditional proposition. So all these three terms are related to conditional proposition. Okay. So converse means the converse of a conditional proposition is obtained by interchanging the antecedent and the consequent. For example, the converse of P implies Q is Q implies P. What we have done here, we have interchanged the antecedent and consequent. Okay. So if any conditional proposition is given there and it is said to find the converse of that, what you need to do, you have to interchange the antecedent and consequent with each other to get the converse. Okay. Like that, the inverse. The inverse of a conditional proposition is obtained by negating. Negating means with dash, bar, whatever. By negating both the antecedent and the consequent. So P implies Q. The inverse of P implies Q will be what? P dash implies Q dash. Okay. And the third, this related to same conditional proposition, the contrapositive. Okay. The contrapositive of conditional proposition is obtained by interchanging and negating. We have to do both. We have to negate as well as we have to interchange. So then you'll get the contrapositive. For example, the contrapositive of P implies Q is, you can see we have interchanged and we have negated also. The contrapositive of a conditional proposition is by interchanging as well as by negating we can get. So these three terms again I'm going through that. Converse by interchanging, inverse by negating, and contrapositive by doing both negating and interchanging. So these all three terms are related to conditional proposition. Please remember that. Now coming to the last term, consistent statements. Okay. Two statements are called consistent, two propositions are called consistent if their conjunction means and, if their conjunction is not a contradiction. Okay. Means consider two propositions are there and you are finding their conjunction. If their conjunction is contingency, if their conjunction is tautology, then they will be called consistent statements. That two propositions will be called consistent statements. If their conjunction is contradiction, means if you are getting only zeros in case of their conjunction, then they will not be called consistent. So this is the last term which I wanted to explain, which we use in Boolean algebra. So please remember all these terms. Questions will come related to this. One of the example I'm going to show you. Listen carefully. See, consider P is there, Q is there, two proposition. P is it is raining, Q is it is cloudy. So P implies Q will be what? As I told you, if you remember, if P implies Q means what? If P then Q. Look at here. The P implies Q means if it is raining, then it is cloudy. If P then Q. So this is proposition. The converse of this proposition will be by interchanging. Q implies P. Okay. Means if it is cloudy, then it is raining. And inverse will be what? By negating both. Okay. P dash implies Q dash. Means if P dash means sense of negation, means if it is not raining, then it is not cloudy. Not negation. P is what? It is raining. P dash is what? It is not raining. Okay. So this is the inverse. And then contrapositive, we have to do both. We have to interchange as well as we have to negate also. If it is not cloudy, then it is not raining. Sorry, P dash. So such question you may have. Okay. So kindly try to understand. If any confusion, you can ask. So I have written in the term of statements also. So this is about converse, inverse, and contrapositive in detail. Now, students, I am coming to this next topic, Boolean laws. Let me tell you, in Boolean algebra, these about 12 Boolean laws are there, and these Boolean laws are very important for this topic. You must have to remember. Otherwise, few of the questions you will not be able to solve if you do not remember this Boolean laws. Few questions are there, you must remember all these. Okay. With some you are already used to in maths, one by one, and just I'm going to show you, and please learn it. Okay. First thing, properties of zero. Okay, properties of zero, as you know in the maths, the same thing. 0 plus p. Here, please remember one thing. Here, plus means not addition. Here, plus means or, and dot means not multiplication. Dot means what? And. It's a Boolean algebra. Okay, remember that. So 0 plus p will be p, same as maths. 0 dot p will be 0. Okay, here p is what? A proposition. Okay. Now second, properties of 1. Here 1 plus p, you are not used to for this. Please remember 1 plus p, 1 plus any proposition will be equal to 1. This is the property of 1 in Boolean algebra. 1 plus any proposition will be 1. 1 plus anything 1. And 1 dot p will be p. 1 dot p equal to p. Okay. So this is the property of 1, and please you are not used to for this, so just take care of this. Okay. 1 plus anything will be 1. Now third is absorption law. Here p plus pq equal to p, or p dot p plus q equal to p. The difference is what? Here plus, instead of plus we have written dot, in dot की जगह पे plus हो गया for the second law. Okay. So p plus pq equal to p, or p dot p plus equal to p. Let me show you p plus pq. If you take common p, so it will be 1 plus q. Just previous law I told you properties of 1. 1 plus q will be what? 1. So p dot 1, and p dot 1 will be what? P. That is what? Right hand side, you can see. So this is absorption law. Okay. No need to derive. Derivation will not come in the examination, but I'm showing you, telling you to make it understand. Now coming to the next law, commutative law, the same law which you have been taught already in the lower classes. But let me remind you, p plus q equal to q plus p. As you know, it can be the place doesn't matter. P dot q will be equal to q dot p. This is what? Commutative law. Associative law also you have been taught in lower classes. See, p plus q plus r equal to p plus q plus r. Same thing for the dot, p dot q dot r equal to p dot q dot r. Okay, here you can see the symbols between inside the bracket and outside the bracket are same, plus plus dot dot. So here associative law works. Okay, now coming to the next, it is involution. Okay, involution law, let me draw here. It is p dash whole dash will be equal to p. Complement of complement will be the same proposition. P double dash, or can be written as p double bar equal to p. Or you can say, do you remember 3 symbols are there? P not p equal to, sorry, p. So any one of these 3 symbols can be used for negation. Remember that. So this is involution law. P double dash equal to p, or p double bar equal to p, or not p equal to p. Okay, it is involution law. You have to remember these laws with the name. Names also very important. You may have the question case state commutative law, state idempotence law, state absorption law. You may have question like this. So you have to remember the name as well as law. Okay. Now the next law is idempotence. Sorry, idempotence law. Here we go. Idempotence law. P plus P equal to P, P dot P equal to P. See, remember that if any proposition is repeating, all the duplicates are removed. Duplicates means one P plus P. So one this will be removed. So it will be equal to P, P dot P equal to P. Consider if you have in an expression P plus P plus P, so will be equal to P. All other duplicates are removed. Remember that. This is called which law? It is idempotence law. Okay, now coming to the next, distributive law. Okay, distributive law, see here dot and q plus r. If you know p dot q plus p dot r, this you are used to for this in maths also. Here dot means please remember why it is called, let me tell you why it is called distributive law. The symbol which is outside the bracket is distributed in this law. ओके दैट्स व्हाट इज कॉल्ड डिस्ट्रीब्यूटिव लॉ. जो सिंबल ब्रैकेट के बाहर होता है वो डिस्ट्रीब्यूट हो जाता है. लेट मी शो यू पी डॉट क्यू प्लस आर, दिस डॉट विल बी डिस्ट्रीब्यूटेड ओवर प्लस. सो पी डॉट क्यू प्लस पी डॉट आर, ये डिस्ट्रीब्यूट हो गया बाहर वाला सिंबल. और सेम थिंग सेकेंड लॉ, पी प्लस क्यू डॉट आर इक्वल टू, so this symbol is outside the bracket will be distributed p plus q dot p plus r. So this is distributive law. Second, knowing these two will be enough for you, but you can learn this third distributive law also, p plus pq. Don't forget to learn it. It may also come in the examination. So p plus p dash q will be equal to p plus q. Okay, this is the third law. Okay. So please remember at least these two laws you have to remember, you have to keep in mind. And if you can't remember, then remember this also. Okay. Now coming to the next, De Morgan's law. De Morgan's law, here it is used for hold as. If there is hold as on any Boolean expression, it is used for that. So you can see P plus Q hold as. P plus Q hold as. Here how it can be broke. See, P will be the complement of first term, complement means by dash, negation, whatever you want to say, plus will be converted to dot, and the complement of second term. In the same manner for P dot Q hold as, the complement P dot Q hold as, so will be the complement of first term means P dash, dot will be, this dot will be plus the complement of second term. Okay. So this is the De Morgan's law. It's also very important. It will be used. You will have the question find the complement of the following Boolean expression. There, this law will be used. Okay. Now, last two, just remember them. P implies Q is equivalent to P dash Q. Remember this. And P equivalent to Q is equivalent to P implies Q dot Q implies P. It is by conditional elimination, by conditional elimination. Please remember all these laws. Okay. And these laws are very important. You know, students, as I told, if you will not remember this, and you have to, not the laws, you have to remember the laws with the name. And if you're not learning this law, few of the questions you will not be able to solve in Boolean algebra. So kindly learn it. Okay, now the next topic is types of Boolean expressions. Okay. Types of Boolean expression, there are two types of Boolean expression. You can see I have written on the screen. Sum of products, that is also called SOP. This SOP word will come again and again in front of you. And the another term is product of sums, that is called POS. Okay. So there are two types of expression in Boolean algebra. There are two types of Boolean expressions, SOP and POS. Okay. So one thing, the first I'm going to tell you SOP, one example of SOP. Let me explain with the, consider a Boolean function, Boolean is f, and the propositions used in that are x, y, and x, y, and Z are the propositions, okay, equal to here. Consider I'm writing on one expression, okay, let's see. Okay, see, this is the example f x y z. Consider f is a Boolean function and the propositions are x y z there. So this is the example of this expression is sum of products. It is an SOP expression. Sum of products, you can see. Let me show you and try to understand. Sum of products dot, as I told you, dot is for and, but to understand I'm telling you x dot y is a product, y dot z dash is a product, y dot z x dash y z dash is also product, x dot y dot z is also product. So sum of products, I think they're getting this point. So I hope now you can recognize if which type of expression you have. So if you're getting such expression, this is called, such expressions are what? Which type of expressions are these? Sum of sum of products. Okay. So this is first. Another is product of sums. Another is what? Product of sums. So this is the example of product of sums. See POS, product. Oh, sorry, wait a minute. Start have written here. Product of sums. You can see three sums are here: x plus y plus z, x dash plus y plus z dash, y plus z dash. These are the three sums, and product of sums. Product of sums. So such expressions are called POS. I think now it's clear both as how now you can. I hope you can identify the expression type, whether it is SOP or POS. Still, if any confusion, you can ask through comment section. Now I'm going to tell you the next topic. The next topic is max term and mean term. Mean term and max term. Okay. Here the terms, two terms here. We have mean term and max term. Okay. I'm going to explain it. The product of all the literals, or you can say propositions. Here it is the definition. So you can say propositions. Try to understand. The product of all the propositions with or without bar. Bar means you can say bar, which is used for negation, bar or dash or this symbol. So the product of all the literals, or you can say the product of all the propositions with or without bar. Are you getting the meaning of bar? Just which is used for negation. So product of all the literals, all the propositions. Please take care of this word, all the propositions. See, let me show you the mean term, example of mean term in this previous expression of SOP. Mean terms are used in SOP. Please remember that. So the product of all the literals, all the proposition, you can see this Boolean function has three propositions, x, y, and z. Okay. So you can see this term has all the literals, all the proposition x, y, z, all three propositions are there. The product of all the propositions with or without bar. Okay. This term is also a mean term. It is a mean term. You can see all the terms are there with or without bar. And this is also a mean term. This term also has all three terms x, y, and z. All three propositions it has with or without bar. So this is also a mean term. This is not a mean term. You can see z is missing here. Product of all the literals. So this is not the mean term. It's a term, but it's not the mean term. Here also x is missing, so it is also not a mean term. So in this SOP expression, only two mean terms are there. This and this. Only two mean terms are there. Okay. So mean terms is product of all the literals, all the propositions with or without bar. Bar or dash, both are same. Okay. I hope the mean term is clear. And remember that mean term is used in SOP. Okay. Now second is second term, you can see the sum of, here it was product of the sum of all the literals, or again I'm telling you propositions, the sum of all the propositions with or without bar. Sum of all the propositions, let me show you in this example. Max terms are used in POS, remember that. You can see sum of all the propositions, x, y, z, all three propositions this term has, so it's a max term. This is also sum of all the propositions with or without bar. You can see all three propositions are there with or without bar. So this is also max term. This is not the max term because x is missing here. So I think the things are clear. The mean term is sum of, what is mean term? The product of all the littles, and sum of all the littles is max term. All. Please take care of this all word. Here only two mean terms. Here only two max terms. Okay. Mean terms are used in SOP. Max terms are used in POS. Okay. So this is very basic topic. You must know clearly. Okay, the next topic is canonical expressions. It is also important topic, you must know. Canonical SOP and canonical POS. Two type the expressions are there, SOP and POS, but one specific type in that, canonical SOP and canonical POS. So first, let me discuss canonical SOP. What is the meaning of canonical SOP? The SOP expression which have only mean terms. What is mean term? I have explained already. A mean term is what? Product of all the literals with or all the propositions with or without bar. So if an SOP expression has only mean terms, then that specific SOP expression will be called canonical SOP. Let me show you with, let me explain with this example. Consider f, x, y, z. Three propositions are there. We have x dash, y dash, z dash, okay, plus x dash, y dot z dash, plus x dot y dot z. Okay, so you can see this term has all the littles, all the propositions with or without bar. This also has all the littles with or without bar. This also has all the littles with or without bar. You can see all this is mean term, this is mean term, this is also mean term, product of all the littles with or without bar. So this expression is SOP, and more specific, it is canonical SOP. Okay, it is what? Canonical SOP. समझ बात SOP है, but specific इसमें क्या है? It is, since all the terms are mean terms, that's why it is specifically called canonical SOP. Such expressions are called canonical SOP. Let me explain with one more example. Let me show you. F x y z. This example, consider x dash x y dash dot z plus x dash y dot z plus x dot y plus y z dash. Okay. See, this expression is SOP expression. This expression is an SOP expression, but it is not canonical. It is not canonical SOP because you can see it is a mean term. Okay, it is a mean term. Okay, but these two terms are not mean term. So since all the terms are not mean term, that's why this is not canonical. It is SOP, but it is not. It is what? SOP, but not canonical SOP. It is SOP but not canonical SOP. SOP तो है लेकिन canonical नहीं है क्योंकि इसके सारे term mean term नहीं है. Okay. So please remember this difference. Canonical SOP, the SOP expression which has only mean terms is called canonical SOP. Okay. Like that, the another is canonical POS. The another term is what? Canonical POS. So another is what? Another is canonical POS. Okay. The same thing. The POS expression which have only max terms are called canonical POS. Okay. Let me explain with this example. One more example here. F, consider x, y, z are the propositions, and we have this POS expression x plus y dash plus z dot x plus y plus z dash dot x dot y x plus y plus z. Consider these. This is a POS expression. You can see it is a POS expression. Product of sums. Three sums are here. And you can see this is a max term, sum of all the littles, sum of all the littles, sum of all the littles. So in this POS expression, each and every term is a max term. So it is maxed. So it is POS, but more specifically, it is canonical POS. Okay, canonical POS, because here all the terms are max term. Okay, Another example. Let me clear this with one more example. Consider this: we have dot x plus y dash dot x plus y dash plus z. Okay, this is also POS expression, product of sums, product of sums. This is also POS expression, but it is not canonical because this term is not a max term. This is a max term, this is a max term, but this term is not a max term. What is missing here? Z is missing here. What is max term? Sum of all the littles. You can see here Z is missing. So this term is not a max term. So it is POS. It is, this expression is POS, but not canonical POS. POS तो है लेकिन canonical नहीं है, क्योंकि सारे जो टर्म है वो मैक्स टर्म नहीं है, सिर्फ दो ही टर्म मैक्स टर्म है, ये जो टर्म है मैक्स टर्म नहीं है. दैट्स व्हाई इट इज अ POS. ओके, बट इट इज नॉट canonical POS. Okay, so you, in examination you may have the question, one expression will be given and you need to convert that normal expression into canonical form. Such question of 2 marks will be there in examination, that I will tell you. Okay, so this is about canonical and canonical POS and canonical SOP. So for this video, this much only, and after this I will make one video for logic gates. Okay, everything in this video I have discussed about the theory and the basic things, about all the basic things and theoretical things related to Boolean algebra. Okay, now next video I will come with I will upload for logic gates. Okay, so for this video, this much only. Okay, in this video I have discussed about theoretical, all basic concepts of Boolean algebra. It will be useful for you for the revision. Okay, and then I will make the next video for logic gates. Okay. In this video, this much only. In this video I have discussed the basic things and all basic, and you can say I have explained the theoretical things related to the topic Boolean algebra. It will be useful for you for the revision. Okay, so for this video, this much only. Thank you. Thank you for watching till end, and if any doubt you can ask, or you can clarify your doubt through comment section. Okay, thank you, all the best.